In this lesson, I'll show you how to verify the centroid of a triangle. The question reads, given the following triangle, and that's shown right here, verify that the point C, which has the coordinates 4 and 0, is the centroid of the triangle OPQ. And then verify that the centroid divides each median in a 2-to-1 ratio. Let's get started. The first thing that I want to do is create a median from one of these vertices to the opposite sides midpoint. You can start with O, Q, or P. I'm going to start with P. I'm going to try to create a median that extends from here all the way to the midpoint of O and Q. So I'll start by finding the midpoint of O and Q. The midpoint is the average of the x and y coordinates, and the formula is shown right here. So the midpoint here will be 4 plus 0, I'm using this formula, divided by 2, and 4 plus 0, because it's the y coordinates now, divided by 2. The midpoint has to be 2 and 2. And I'll plot that right here. So we have a line that extends a median from P all the way to this midpoint. Now through visual inspection, it appears that this line is passing through the midpoint, but we want to do this algebraically just so that we're 100% sure. What I'll do next is find out the slope and y-intercept of this red line. To find the slope, we can use this point along with 8 and negative 4. So the slope is y2 minus y1 over x2 minus x1. I'm trying to create an equation that looks like this. Y is equal to mx plus b. So I need the slope and I need the y-intercept. And what I'll do with this formula is substitute the point 4 and 0 into x and y and see if the left side of the equation equals the right side. If it does, then indeed the median from P to here passes through the centroid. So let's continue. y2 is negative 4 minus y1, which is 2, 8 minus 2. We get negative 6 over positive 6, which is negative 1. The slope is negative 1, and that's expected because it's going downwards. So I just found out what m is equal to. It's negative 1. I'll write down y is equal to negative 1 x plus b. Now to find out the y-intercept, I can substitute the point 2 and 2 into x and y and solve for b. So I have 2 is equal to negative 1 times 2 plus b. We bring this over, where we get 2 plus 2 is equal to b, and that's 4. So our equation is y is equal to minus x plus 4. If I substitute the point 4 and 0 into x and y respectively, I should end up with the left side equaling the right side if it in fact is the centroid. So I have 0 is equal to minus 4 plus 4. 0 is equal to 0. Therefore, this median does pass through the centroid. Now we have to do this for all of the medians. We have to do this for Q passing through the midpoint of O and P, and we have to do it for O passing through the midpoint of Q and P. That's a lot of work. And it turns out that if we use this method, it will also show that the point C lies on the medians of OT and QS. Now to find the answer for part B, where we have to verify that the centroid divides each median into 2-to-1 ratio, we have to find the length from P to this point, its length, and then we have to find the length from C to this point. If this one is 2 times bigger than this, then we verified that it divides each median in a 2-to-1 ratio. Let's go ahead and do that. I'm going to find out the length from point P to C using the distance formula, which looks like this, where distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. x2 is 8 minus 4 squared plus y2 is minus 4 minus 0 squared. And that minus should be within the brackets. I don't need a calculator for this. 8 minus 4 is 4 to the power of 2, plus minus 4 minus 0 is minus 4 to the power of 2, 16. So we have 16 plus 16, the square root of 32. We'll find out the decimal version of that number in a moment. But now I want to find the distance from here to here. I'll show my work in this space. We have x2 minus x1, so 4 minus 2 squared plus y2 minus y1, 0 minus 2 squared. 4 minus 2 is 2 to the power of 2 is 4 plus 4. We have the square root of 8. Let's find out what that is. The square root of 8 as a decimal. It's equal to 2.82. And the square root of 32, divide that by 2, we end up with 2.82. This means that the centroid does in fact divide each median in a 2-to-1 ratio. Of course, I've only verified from P to this midpoint, but the same would be true for all of them. And there you have it. That is how to verify the centroid of a triangle.